Hello everyone, I myself Vishal Sokia. Now I am going to present a video presentation about discrete and continuous random variable. The first part of the presentation will be presented by me and further it will be carried by my partner Rishabh Saringya Bordoloy. So at the very first, in the slide we have the content part. In the content, the first we will discuss about introduction about random variable, then types of random variable, discrete random variables, continuous random variables, PDF of continuous random variables, and PDF of discrete random variables. Here is a random variable. A random variable is a variable whose value is unknown or a function that assigns value to each of experiment's outcomes. To understand the random variable, here we give a example. In the example, if we toss two coins simultaneously, we get sample space head head, head tail, tail head, and tail tail. And let us assume a variable x which denotes number of heads. Here the possibility of the possibility of getting head head is 2, head tail is 1, tail head is 1, and tt tail tail is 0. And in the diagram we see sample space is head head, which is real value 2, head tail getting of probability of getting head is 1, so the real value is 1. Then here the types of random variable. There are two types of random variable: discrete random variables and continuous random variables. Discrete random variable. A discrete random variable is one which may take only a countable number of distinct values such as 0, 1, 2, 3, 4. Discrete random variables are usually but not necessarily counts. If a random variable can take only a finite number of distinct values, then it must be a discrete. To understand the discrete random variable, here we give an example. If we take a dice and throw it, then the possibility of getting odd number. If we consider S is number of odd numbers, and sample space 1, 2, 3, 4, 5, 6 we get. Now probability of getting odd numbers in when we getting in dice 1, then the probability of getting odd numbers is 1. When the dice number is 2, then the probability of getting odd number is 0. And similarly for 3, the possibility of getting odd number is 1, for 4 0, for 5 1, and for 6 is 0. And here the diagram.
Respected teacher, I am Rishabh Saringya from MCA second sem. Today we are going to discuss about continuous random variable. A continuous random variable can be defined as a random variable that can take on an infinite number of possible values. The probability that a continuous random variable will take on exact value is 0. A random variable x is continuous if possible values comprise either a single interval on the number line or a union of disjoint intervals. Continuous random variables are used to denote measurements such as height, weight, time, etc. Here we can see some examples of continuous random variables. The height of a person, the time taken to complete an examination, the amount of milk in gallon, the weight of a fish, such that times required to perform a job, and also financial ratios, etc. Those are some examples of continuous random variables. In here, we can see discrete variables and continuous variables. In discrete variable, there are countable supports, probability mass function, probability assigned to single values. Each possible values has strictly positive probability. In continuous variable, uncountable support, probability density function, probability assigned to intervals of values, and each possible value has zero probability. Now, probability density function, sorry. The probability density function of a continuous random variable can be defined as a function that gives the probability that the value of the random variable will fall between a range of values. The probability density function is just the distribution form which a continuous random variable is drawn, like the normal distribution, which is the PDF of a normally distributed continuous random variable. Here PDF means probability density function. The probability density function of discrete random variable. The probability density function of a discrete random variable, it is simply the collection of all these probabilities. And that's it from my side. Thank you, sir.